Alright. Number 71. 71 reads, a force of 40 newtons accelerates a 5.0 kilogram block at 6.0 meters per second squared along a horizontal surface. That's all the information I'm given. So number 71, I got a force, it's equal to 40 newtons. I have a mass, it was 5.0 kilograms, and acceleration, which is 6 meters per second squared. It's all the information that I'm given, and it's on a horizontal surface. I'm going to go on and draw a free body diagram. Don't be scared to draw you a picture ahead with these free body diagrams to get a visual representation about what's happening. So here's my blocks. And here's the forces that's acting on it. First, I have the force being applied. This is a horizontal force. I'm going to call it the force applied because this is the force that I'm applying. Man, that 4 looks horrible. So this is equal, the force applied, equal to 40 newtons. Then I have a friction force going backwards, opposite of the motion. And I know the box is moving, so I know that it's kinetic friction. So I'm going to put UK down there. And then I have 2 other forces going on because the box is not falling through the floor. I know that I have a force of gravity. And since it's not falling through the floor, there has got to be a force negating it, which we call the normal force, which is always perpendicular to the surface that it's on. So there's all my forces being applied to this box. Now we can start answering some questions. So let's go to A, Part A. Part A says, what would be the box acceleration if the surface were frictionless? So I no longer have friction on the surface. So there's no friction going on. So this force is now gone. So what we're looking at is a net force of 40 newtons going in the x direction. So I have net force equals 40 newtons. The reason I know that is because normal force and the force of gravity cancel each other out. I don't even need it. And then I have the force applied. It's the only thing going in the x direction. So in this, I'm going to be looking for an acceleration. So force equals mass times acceleration. Acceleration equals force divided by mass. In this case, we're dealing with the net force. I have net force, in this case, which will equal 40 newtons divided by the mass of the box. The mass of the box is given to you to be 5.0 kilograms. Grab yourself a calculator. If you're not confident in yourself, I'm pretty sure it should be 8. So 8.0 meters per second squared. I'm grabbing a calculator because I'm going to need that thing later. Alright, so there's the answer to A. So going from A, let's go to B. B, how large is the kinetic friction force? So B, how large is kinetic friction force? I now have everything back to my original diagram and my original free body diagram with kinetic friction force going opposite of the motion that's going to the right. But there's some information I'm not given. You cannot use force of kinetic friction equals kinetic friction coefficient times normal force. Why are we not able to use this at this time? Is because we do not have a kinetic friction, we do not have a kinetic coefficient to go with this. So this is not known. I could find the normal force, but I'm trying to find force of kinetic friction. You got to find another way. So, option 2, go in here. I'm looking at this. Everything in the y direction's canceling out. I know it's gone. So, I look in this x direction. There's 2 forces going on here. I have force being applied, which is 40 newtons, and I have a kinetic friction force, which I'm trying to find. You need another option. This is your other option. What is the net force? Your net force can be solved for by using your mass times acceleration for the problem that they gave you. In the beginning, you were given a mass and an acceleration. Your mass does not change, no matter what. And this is the key to behind why I can do this. My acceleration of 6.0 meters per second squared is for the whole system. For all of this. Everything going on in this purple box. We put it in purple because you remember purple's important. It looks awesome on the board. So I can calculate out the net force, which is equal to the mass times acceleration. So the mass is 5.0 kilograms and the acceleration is 6.0 meters per second squared, which will equal 30 newtons. That is the summation of all the forces going on. So the y's cancel each other out and the x's end up giving me a net force equal to 30 newtons. And since you remember that the net force is the summation of the forces, you remember net force is equal to force applied plus force of kinetic friction. I'm going to make to the right positive and up as positive. So I can start filling in information, but I'm trying to find, well, let's do it this way. I know my net force, I just solved for it, and I know my force applied because it was given to me. So now I'm going to solve for the kinetic friction force, which will equal, the kinetic friction force is equal to the net force minus the force applied, which will be equal to my net force, 30 newtons, minus force applied, which I'm given, just 40 newtons, and it will be negative 10 newtons. I gotta ask myself, does that make sense? Absolutely makes sense. Why? Because the force of kinetic friction is going in the opposite direction of my force applied. So it should take away. It should be less than 40, which it is. Hallelujah. Alright, now we're looking at part C. So we're going to go part C. Part C asks, what is the coefficient of kinetic friction? Alright, coefficient of kinetic friction, you know only one formula that uses that. You have force of kinetic friction is equal to the coefficient of kinetic friction times the normal force. So, I know what my force of kinetic friction is. I do not know. I'm trying to find the kinetic coefficient. Normal force, I do not know, but I can solve for it. So the first thing we got to do is solve for my normal force. To get that, it's just the opposite of weight, which is the force of gravity. So, no. Normal force is equal to the opposite of force of gravity. So, force of gravity will be equal to mass times gravity. In this case, my mass is 5.0 kilograms times gravity, which is negative 9.81 meters per second squared. Do that in my calculator. Find force of gravity is equal to negative 49.05 newtons, which means, since my normal force is equal in magnitude and opposite in direction, the normal force is equal to 49.05 newtons. Which means I can now solve for the kinetic coefficient. Do it in red. So my kinetic coefficient, force of kinetic friction equals kinetic coefficient times normal force. Kinetic coefficient is equal to the force of kinetic friction divided by my normal force, which is equal to force of kinetic friction, we saw to be negative 10 newtons, divided by the normal force, and my normal force is 49.05 newtons. Newtons cancel, leaves me with negative 0.2039, right? Yeah, 39. There's no units with it, and since it's a coefficient of friction, there's no need for the negative. It's kind of like the magnitude thing we talked about in class. So the answer to C is 0.2039. Oh, good question. Got any questions? Come see me in class.